Hello, everybody. I'm very happy being here, and many thanks for having me. So this is my card. I will start with just presenting myself. My name is Fanis Prodromou. I'm a Google developer expert for Angular. I'm a senior Angular developer at the company ASI. I'm a co-organizer, like the guy said previously. I'm a co-organizer of the Angular Athens Meetup, and I really like this kind of title. I'm an Angular content creator. If you're going to connect with me, here are my contact details. Twitter or X. I think that I have to change the logo here. Prodromou F, Angular Lab. So this is an amazing place where they are kind of community, and they have also a blogging space. And I try to write my blogs there at their blog, actually, Angular Love. And of course, this is my official one, and I mirror all the articles to my official one. And LinkedIn, Prodromou F. If you would like, please connect with me. And this is my YouTube channel, Code Shots with Fanis. If you haven't yet subscribed, please do so. Go there, subscribe, and I'm sure that you will find something that you will like. If, however, I have something like more than 60 videos, this is a bit old screenshot, and more than 7K subscribers. If you see that something is missing and you would like to see that, just send me a message, and definitely will be added in my to-do list. So today's talk, the title is Learn how to use Angular's defer block to improve performance. And I have been thinking about this talk, and I have been thinking, how can I start? And I think that presenting a topic and giving the solution without explaining what the problem is, I think that we can kind of miss that. So what is the problem? So let's say that we have this kind of application, and we'll have three features. We'll have the yellow feature, the cyan feature, and the purple. If you click the yellow, you can see something like that. If you click cyan, you can see something like that. And if you click purple, you can see something like that. Three different features, and everything are fine. And now let's see a bit the configuration, the routing configuration that we have. We have this one for yellow, we have this one for cyan, and this one for purple. Nice. And now let's see what is happening during the compilation. Angular knows that we have three features, and during the compilation process, it detects that we know that we're going to have all of these three features eagerly loaded. And what it does, it includes everything into one bundle file, into the main.js, and everything works just fine. So what is the issue if everything works just fine? So imagine that you have an enterprise application. So the issue here is that we have a violation to core web vitals, and this is the LCP, the largest contentful paint, and time to first byte. The problem is that the main.js file will become very big, and the users will have to wait until all of this JS file got downloaded, which is, of course, not a good thing. So what is the solution? The solution to this problem is something that we have faced, and we already have this as a solution, actually, and this is the code splitting. So the code splitting is not something new, and we already have that in Angular, even before Angular 17. And how can we achieve that? By changing, one way actually, is by changing the routing configuration. Please note that here I have my path, and I have a load component function, where I have to provide the path of my component and then the actual class name of that component. So this is the routing configuration for yellow, for cyan, and for purple. Nice. So how about now? What is happening during the compilation? Again, Angular knows that we have three features. And during the compilation, what it does is that it creates different chunk files. We have the chunk yellow, chunk cyan, and chunk purple. Of course, we have the main.js as well, but as of the features, this is what we have, which is much better. How about now? This is a question. How about if we have this feature, which is a very big feature, and we're going to split that in half? How can we achieve that? And when I say to split that in half, what I mean is that if we have the chunk cyan 1, a chunk cyan, to split that to chunk cyan 1 and chunk cyan 2. You might be wondering here, Why do we have to do that? Let's think that for a while. Let's assume that we have a user A, that follows a user flow A, okay? And this guy activates the chunk CN1. And then we have another user, the user B, that follows another flow. And this guy activates the chunk CN2. So what is happening is that whenever we have a UX designer, they are designing a feature, and that feature has different flows. Why do we have to activate everything for all the users? Not all the users visits everything, right? So how can we achieve that? As of today, what we can do, or as of today meaning before Angular 17, what we can do is to dynamically load the components. I have a video that in my YouTube channel that I explain extensively how to do that. But in a nutshell, what we can do is providing the path, like we did in the routing configuration. For example, I want to have my CN component, and this is the class name, and this returns back a component instance, this guy here. What we have to do then is we have to use a container. Let's say that this is my view container ref, and the view container ref has the method create component, and we have to provide into that method this instance that we have just created. And this works great. This is a great feature. How about though, let's think a bit. How about if we have a very big feature? CN component is very big, or we have a very slow connection from the user side, or a combination of that. Wouldn't it be much better for a user experience, from a user experience perspective, to have a loading indicator just to indicate to the user that, you know what, something is loading? And how about cleanup? We need also to make sure that if I invoke more than once the create component, I don't want to create more instances, or in any case, to clean this up. And of course, error handling. You might be wondering here, why do we need to have an error handling here? So let's face that for a while. Let's assume that you have an application, you are using your mobile, and you are into the metro, into the subway, okay? And you are visiting a page, and before even clicking a button, what is happening is that you are offline, and then you're clicking the button, and nothing is happening because you are just offline. So in that case, it would be nice to inform the user that something bad happened. This is why we need to have an error handling whenever we are dealing with these kind of cases. So all of these things, we can do that, and we can do that manually. And what we can do is to create something, a reusable function, to encapsulate all of this logic. And we have to keep in mind that this is for the user experience, and that function should be in a way to support also a DX, a developer experience, so that our team members can use that easily. And do not forget, we do not have to import the CN component into the imports array. If we do that, then this feature is no more lazy loaded, but eagerly loaded. And now that we have seen kind of the problem, let's see the defer block and what the defer block is. So the defer block is a way of creating chunks, like we saw previously, that we have the AppCN1 and AppCN2, a way to create chunks just by wrapping a component selector with a defer block. And this is our templating. So just by doing that, without dive deeper into the defer block, let's see what is happening. We still have three features. We have the yellow, we have the purple, and in the middle, what we have is the cyan. And please note here that now we have a component tree. A component tree where Angular recognizes that one of the components is wrapped with a defer block. And what is happening during the compilation is that now we have the chunk yellow, we have the chunk purple, and we have chunk cyan1 and chunk cyan2. This is amazing. And like we said previously in the use case that we presented previously, is that perhaps we have different users. We have user A and user B. So wouldn't it be great to have a way to activate this kind of, or to state it better, to fetch and display this component on a specific condition, on the Boolean expression? So this is why we have this kind of keyword. This is the when keyword, and it accepts just a Boolean expressions. And when the isVisible becomes true, at that point of time, we fetch and display the cyan component. And now let's see what else do we have from the defer block. We also have the placeholder. And you know what? To understand why it's important to have the placeholder, let's forget for a while this kind of slide. And let's think now that we have a user form page where you're entering an application and you have just a form and you have to enter your name and your username, whatever, doesn't matter. And into the name, you have the label and then you have the input. If you focus into the input, what you can see is that it says enter your name or enter your username. This is the placeholder. And it's a way to improve and increase the user experience. It guides the user. Now, let's get back into the slide. And in the same way, we have the placeholder. So the placeholder will be there for the user just to indicate to the user that something will happen here. And of course, whatever we have here into the placeholder will be overwritten with the cyan's content. The placeholder, sometimes to avoid having a flickering, we can say that, you know what, I want the placeholder to be there for a minimum amount of time. I don't want to be something like visible and invisible right away. So again, to increase the user experience, we can be like, I want there to be for 500 milliseconds or 1 second, 1s. And then we have the loading, which is a very nice one. So let's think for a while. What are we achieving with a defer block? We are achieving, actually we are defer loading. So since we are defer loading, what we can do is to display a loading indicator. But you know what? Something is loading, especially in cases where we have a very big component or when we have a slow user connection. And again, to increase the user experience, we can be like, I want the loading indicator to appear after 100 milliseconds or for a minimum of 1 second. And by combining this one, it means that if my cyan content is there in less than 100 milliseconds, I won't see that. But if I see that after 100 milliseconds, it will stay there for 1 second. And then we'll have the error block, the thing that we said previously. How about if we are offline? In that case, we can easily inform the user that something happened, failed to download or whatever, you name that. So this is how we can use the defer block. And currently we have seen when, and then we saw the placeholder, loading, and error. Okay, so let's focus now just on the when part. So we have the when, but wouldn't it be much better to have more control when to display something and when to fetch something? So let's now see the on keyword. So other than when is visible, the thing that we saw previously, we're going to have on idle. So idle is a preserved word, is an implementation from the Angular framework, and it means that actually the underlying implementation is the request idle callback. And whenever we have this kind of event from the browser, we know, or Angular knows, that at that point of time, the browser has nothing heavy to do, so let's fetch and display the cyan component. And again, it's important to know the underlying implementation of this one. Other than the idle, we have the immediate, which means that at the template execution, during the template execution, we will fetch and display the cyan component. And then we have the interaction. And please note here that we have the implicit and explicit, and we will see the explicit in a sec. So what is happening with this one is that, as you can see, we have the placeholder. Whenever we have the interaction in an implicit way, we have to have the placeholder. And why is that? With the on interaction, what is happening is that we will fetch and display the content of the cyan component whenever the user interacts with this block. Or to state it better, let's assume that we have this kind of thing, this kind of block into our HTML page. What is happening to the user is that the user will see just the placeholder, which is this kind of span. And when the user clicks that span, at that point of time, we will fetch and display the cyan component. And this is the implicit way. But perhaps you're going to have something more explicit. And in this case, we can be like on interaction, and we can display here, we can here a trigger point or whatever you name that, which is an template reference variable. And in this case is a button. And whenever we click to that button, we fetch and display. And please note that we do not have any click event here. This is happening behind the scenes by the interaction. So we just saw the implicit, and this is the explicit one. In the same way, now we have the hover. Hover means that whenever the user, we have here the placeholder because this is the implicit, whenever the user hovers over this placeholder, we will fetch and display the cyan component. And how about now the explicit? So the explicit one is that, of course, we have to define here a trigger point, or whatever, you name that. Which means that when the user hovers here into the button, at that point of time, we will fetch and display the cyan component. And then we have, in a similar way, with implicit and explicit, we have the viewport. So I really like this kind of thing, the different viewport, and the underlying implementation of this one is the intersection observer. So when this kind of span enters the viewport, at that point of time, we fetch and display the cyan component. And this is the explicit. The explicit one will have to define the trigger point. When this button enters the viewport, at that point of time, we'll fetch and display the cyan component. And this is the last one in terms of actions on timer. And again, the underlying implementation is the set timeout, which means that after 1000 milliseconds, or this could be even just 1s, after 1 second, we will fetch and display the cyan component. And how about what if the component is super heavy? And we have a combination of a super heavy component, and at the same time, we have a very slow connection from the user. Wouldn't it be great to prefetch this kind of chunks? Because this is what we are doing. We are creating chunks. And the answer is yes, we can prefetch that. And as you can see here, what we have is the defer block on action, and we can prefetch on specific action. And we can have any combination between on and when, and we will see all the examples. An example with on action and prefetch on action is, for example, let's say that I want to defer on timer after 1 second, but I want to prefetch that on immediate. During template execution, I want to download this kind of chunk. Just download. We're prefetching that. We're not displaying that. We will display after 1 second. And then the other combination is on and when. An example could be on timer 1 second and prefetch when it's true. For example, we can have a variable, and when that variable becomes true, we can prefetch that. Another combination is when and on. For example, when is true and prefetch on timer. After 1 second, we will prefetch that. And the last one is when and when. When is true, prefetch when is something true. And before we go into the live coding, I think that I forgot one more case here. What we can do is that we can combine more actions here. For example, we can have when Boolean expression, comma, let's forget for a while the prefetch, when Boolean expression, comma, on immediate, on idle. And we can have more actions into the same defer block, and they act like a Boolean or, whatever comes first. And now let's go to a live coding, which is always a bit stressful. So let me show you what I have here. I'm already running this application, and let's go to the browser. So this is a very small application that I have. Let me open this guy as well. And I think that I have to zoom in a bit, both of them. So what I have is just a drop down here, Angular 2, Angular 4, Angular 5, up to 17. And then I have here, how long have you been using Angular? And I don't use that one, it's just for real estate. And let's focus into this guy. So if I select Angular 14, nothing is happening. If I select Angular 17, now what we have here is another feature, which says how much do you like Angular 17 features. I very much like logo, the documentation, the control flow if, control flow for, control flow switch, control flow defer, of course, and the automatic migration to new built-in control flow. So these are just a subset of the features that we have in Angular 17. And this is just the application that we are going to work with. And now let's go to the VS Code to see what we have. So into the VS Code, I have just a build here, and the main JS is 2.89. 2.89. And how about now we have a code splitting? So I will comment this out, like we said previously, and this time I will have a load component. And immediately, my main JS is 191K. Much better, right? And we have a chunk here for the main component, and the main component is 1.4. And of course, if we go to the browser and continue working with the application, we expect everything to work as expected. Here we have everything like we saw previously. Nice. And now let's go to the main component, which is this guy. I have it open. I will close the app route. We don't need it anymore. And as you can see here, into the template, what I have is just the Angular survey. How about if we now switch that into a chunk? I will try to wrap that into a defer block. Let's move this guy up. And what is happening now is that we have one more chunk. So the main JS remains like we saw previously, but this time the main component is no longer that big. Is 1.6 because we just have another chunk, just because we did this thing. And if we go to the browser, we expect everything to work as expected. And of course here, if I change that guy, not font, my JS, we expect to have here all the chunks. Yeah, here are my chunks. And of course, if I start playing around with the application, we expect everything to work as expected. Nice. Now, while being here, let's see what can we do. For example, we said previously that we have the placeholder. And the placeholder could be something like, this is a div, and I want my div to be, this is a placeholder. Let's save. And now let's go here and just reload the application. And as you can see, if I reload somewhere here, you will see that we have that this is a placeholder, which is a bit annoying. It's a bit annoying to see that guy there just for a while. That's why we have here a minimum. And I can say that I want to have that guy there for a minimum of 1 second. And if I reload, we can see that at least now we can read that it says this is a placeholder. Of course, this use case, it's not that useful to have a placeholder into this case, but you know, how can you adapt that into your needs? And then other than placeholder, we said that we also have the loading. And the loading, again, we can have something like that, div loading. Let's see. If I go now here and reload, what will happen is that we will see only the this is a placeholder, which is the placeholder block, but we're not seeing the actual loading indicator. So let's give that a try. What I'm going to do here, I'm going to create just a button, and the button will have this is visible Boolean, is visible by default is false, and let's use that here. I will be like, when is visible. So I would like to fetch that as soon as this becomes true. So let's go back again to the browser. And as you can see, we're just seeing the placeholder here, and I will toggle, and we can see the loading indicator. And again, it's a bit annoying. Let me do that once more. I will toggle, and we can see that we have the loading indicator. But like we said, we don't like it that much. So we can be like, I want to have that. I think that after 100 milliseconds and for a minimum of 1 second, something like that. So if we now go to the browser and toggle, we do not see it anymore because the response goes very fast. So let me do that once more, but this time I will use a throttling. Perhaps I can go with the Wi-Fi and toggle. And now we can see that we have the loading indicator, and after a while, we can see the actual content. So let me remove throttling from here and go back. And how about the error block? So the error block, we can be like, yeah, something like that, just an error. And how can we see the error block? In this time, I will go completely offline, and I will be like, okay, let's toggle that. And we can see the error block here with something failed. So let's go back again into the no throttling. Nice. So let me remove everything from here and this guy and this guy. And now let's go into the Angular survey. So we are focusing into the chunks, and we can see that we have here this kind of chunks. And if I now go into the Angular survey, what I have is the following. I have all of these fields and the date picker and the thing that we said previously, the date picker and the dropdown. And this is actually the Angular 17 features, the one with a slider, where I'm presenting that whenever the Angular version is 17. How about now, if we change that to defer, and I have here just a when block. Immediately we can see that we have more chunks here. So we have more chunks, and this is, yeah, like we said previously, this is something that we will activate, we will fetch and display when the Angular version is 17. So let's see that in action. And you know what? What I'm going to do, I will clear everything, and I will select here 17. I think that I have that many zoom. And if I click Angular 17, we can see here that we have just downloaded this kind of chunk. This wasn't part of the application, of the browser, sorry. And of course, we can utilize here different things. For example, let's say that I have here a loading indicator, and the loading will be something loading, and we can have here a placeholder, and the placeholder will be Angular 17 features, yeah, Copilot. I like that. And if we go now here, what we can see is that we have here the Angular 17 features, and of course, these will be overwritten at the time that we have the actual content of the component. And how about prefetching? So let's see that. Let's see that this kind of thing, Angular 17 features, is a very big feature, and at the same time, we have a very slow connection. So let's say that the user has something like that, and clicks Angular 17. It wasn't that slow. I will do that again, reload, but this time I will pick slow 3G. So let's see. Angular 17, and the user has to wait and wait and wait. And it's a bit annoying sometimes. So in this case, what we can do is to prefetch. So what I'm going to do here, I will type prefetch on, let's say, immediate, which means that during the template execution, I would like to prefetch this kind of component. So let's now go back again here. And again, what I'm going to do, let's clear everything, slow 3G. I will click Angular 17, and the feature is already there. And the reason is that we have just prefetched that. And sometimes this is super handy for different features. So this is what I wanted to show you in terms of how to use the defer block. And now let me switch VS Code, and I will show you how to unit test that. Again, this kind of code is part of a video that I have recently uploaded called Project with Profanis. And what I would like to show you, actually, I'm not going to explain everything in terms of how to unit test that, only the critical parts. And what I have here is how to defer when it's visible, how to unit test the defer when it's visible, on idle, viewport, timer, interaction, hover, and immediate. And something very interesting is how about if I have nested defer blocks? So let's see that. Let's start with the first one, which is when it's visible. Perhaps you have used to have an after each and before each, something like that. But for the sake of this kind of presentation, I have into each unit test item, I have a component, which is on class. I have my test bed, I have my fixture, and I have everything actually into the same thing, just for the sake of the presentation. So let's see what we have here. From top to bottom, what we have is just a component here, this guy, just focus here. And we have a button with this kind of attribute, data test, which helps for the querying. And then we have this click is visible, which we are just toggling that. And then we have we have the defer block with a when keyword. And we know that whenever this guy becomes true, then we will have the empty defer block into our page. Nice. So this is our component. And now what we have to do is actually to configure the testing module. And something very important is that we have now a new option, the defer block behavior. Let me go into the playthrough. And the defer block behavior has two options, the manual and the playthrough. So the playthrough, let's start with this one, is the way that we have used to unit test, is the way that our environment mimics the browser. And the manual is the way that we have to explicitly define the defer block and the state that we want to unit test. It sounds a bit abstract. We will see that in action in a sec. So in this version, I think, let me see, which version do I have? I have 17.1. I think in this version, manual is the default one, but there is one command that they will change that, and now the playthrough will be the default one. It makes more sense to have playthrough the default one, and you will understand why. So here what I have is, I have my test bed, configure testing module, and then providing the playthrough. Nice. Then what you have to do is with the test bed, create component, I have my dummy component, and now I have my fixture. The next thing I have to act. And since we have the when is visible, what you have to do is just dispatch an event. What kind of event? A click event, where into that button with that attribute. So we are dispatching the event, we are detecting the changes, of course, and I have also here the fixture when stable, and I have that in case this guy has any dependencies that we wanted to wait for. And then I have this kind of expectation. So if I focus to this guy, so let me focus here, and then I will copy my relative path, go to the terminal, and ng test with the option include. I expect that to be green. And yeah, so we have one success unit test. So this is what we have in terms of when is visible. So let's collapse that. And now let's go to the on idle. Like I said, I'm not going to go into details for everyone, but we can just have a very quick overview. So for the idle, if you remember previously, what we said is that it is very important to understand the underlying implementation of each action. So the underlying implementation of the idle is the request idle callback. So whenever we are unit testing, what we are doing is that we are thinking, can I mock that? Can I spy that? This is what we have in mind, right? So I had this question to myself, and perhaps you can answer yourself as well. Does it worth mocking the request idle callback? I think no, in that case. And that's why the defer block behavior here is manual, which means that we have to explicitly define which defer block we have to unit test. And let's see that. And this is where we have to focus. And what we are doing is that with the fixture is what we just created from the create component. With the fixture, we have one more property now, and that property is get defer blocks. And we are saying that, and please note that this is a promise. That's why we have to have an await, and we are defining then the index. So let me make it more clear. How about if we had here more blocks? So this means that this is the first one, the second one, and the third one. That's why we have to define that I'm going to start working only with the first defer block. Let me undo everything. Nice. So as soon as we have the defer fixture from that defer block, then we have to render the state. And the states are complete, error, loading, and placeholder. Perhaps you want your unit test to unit test this kind of thing, the placeholder, or you want to unit test the error block or the loading block. You have to define which state you want to render. And of course, if I have that, let's focus to this guy, copy a relative path, and if we go and test that, I expect that one to be green as well. Nice. So let's move on. So that was the idle. Let's see what else do we have. Then we have the viewport. And again, for the viewport, like we said previously, the underlying implementation here is the intersection observer. And it doesn't worth mocking this thing. Perhaps there is a solution, there is a way. I'm not sure of that. But to my understanding, or from my point of view, I don't find any reason of mocking this kind of thing, the viewport. I would prefer to have the manual here, and we'll have to do the same thing what we did previously. We'll have the defer blocks, render the state, and that's it. I'm not going to test this out. And then we'll have the timer. So for the timer, we can go with a playthrough. And the reason is that, what is the underlying implementation of the timer? Do you remember? This is the set timeout. So since we have set timeout, we can use the fake async and then use just a tick of 1000, similar to our waiting time. And then the rest works as expected. And then we have the defer on interaction. Similar case, we can go with a playthrough by just providing a click event here, no more than that. If you remember, the interaction is when the user interacts, in that case, which is the explicit one, when the user interacts with that button. So in this case, we don't have to go with a manual. It's okay to go with a playthrough, since we have a user action. And I think this is what we can have in mind. Do we have a user action? Yes, let's go playthrough. If not, perhaps we can have the manual. And then we have hover. And again, in this case, what we have is the defer on hover, the explicit one. And since we have this kind of trigger, whenever the user mouse over here, then we display the empty defer block. And since we mouse over or mouse render, this is the event that we have to dispatch. So let's move on a bit. And then we'll have the on immediate. Again, same thing, playthrough. We expect to have this kind of template on template execution. Let me close this guy. And now let's go here into the nested defer blocks. And what we mean with nested defer blocks is that into the defer block, we can have a nested defer block, which is kind of interesting. Very valid code, but how can we unit test that? So like we said previously, perhaps we can have more than one defer block. So this is the first and this is the second. And again, the defer block, this guy is the complete state. And the complete state has one defer block. And same here. This is the complete state of the outer defer block, and this is the index of the nested defer block. To explain that better, when I say that we have the complete state, what we're missing here is perhaps the placeholder. So here now it's more obvious. This is the complete state, and this is the placeholder. And why am I sharing that with you? So let's see. Well, I'm sharing that we have the first and the nest and all the nesting. So what we have to do to unit test that is that, like we said previously, we have to grab the fixture, grab the deferred blocks, and grab the first one, this guy. And then we have to render the complete state, because this is my complete state. And you know what? The complete state internally has another deferred block. So now we have the deferred fixture, which is the outer, which has internally deferred blocks. So let's go there, grab the first one, render the complete state of the nested, and as soon as we then we can have our expectation. So this is the last thing that I wanted to share with you. And now in terms of live coding, and we can go back to our slides, 2 or 3 more slides, and we are done. And there is one violation, or just one point just to keep in mind, and this is the cumulative layout shift. And why is this a warning, let's say? The suggestion is to use the defer block below the fold. So this is our viewport, this is the scrolling, and this is below the fold. And why is this kind of suggestion? Well, whenever we have here, let's say, a defer block, whenever this guy is visible, it will shift all the content to the bottom, right? So this is something to keep in mind, but at the same time, if you have the placeholder and the placeholder has the dimensions of the expected component, we know the width and we know the height, so we expect not to have any shift of the content below. So either or, if you use it below the fold or if you use it above the fold, make sure you have a correct placeholder.